Hello. Hi,
Hello,
Priya. How are you?
I'm fine. How are you?
All good. Okay. So we had discussed about volume and surface of three-dimensional object, right? Okay. So let's start solving some problem on that. Before that, I would like to give you some concept related thing. Volume and surface area of three-dimensional object. Okay. So this is our heading. Now, like, what is prism? Do you know prism?
Prism is like a 3D shape. It's
Yeah,
like
it's
the
a it's a 3D
like two of
object.
the faces are like triangles.
Triangles, rectangles, square, anything. Okay, it can be anything. So the cross section area, like the cross section figure, could be anything. It may be trapezium, it may be rectangle, it may be square. Okay, so I draw prism here. So just understand, this is a prism whose cross section is trapezium. Okay, so if I try to draw this way, if I try to put this in 3D object in two-dimensional figure or in 2D plane, it would be like this. Can you imagine that? This is prism. Okay, this is a prism. Okay, and its
No, I
cross.
can't see you.
Yeah, yeah, sorry, I'm really sorry, I didn't share that and I started directly. Okay, sorry, my bad. So this is basically, the topic is volume and surface area of 3D object. Okay, and the prism is basically, this is a prism whose cross section uh, region is basically trapezium, right? So
Okay.
this is trapezium. You can understand this way. Just a second. This is trapezium, right? So the cross section is trapezium everywhere. Like if you cut this object by a plane perpendicular to this surface, okay, you will get trapezium everywhere throughout the object, right? So means the area is common throughout its length. Are you getting that? See, the length of this prism is, let's say, L, and the area of this cross section is A. So you will definitely verify that this cross section A is repetitive. It's going along the length, isn't it? All over, it's
Okay.
just A. If you cut the object, you'll find the cross section as trapezium only, right? So in that case, so the volume of the prism would be A into L, right? Which is area of cross section and length. Okay, area of cross section into length. Understood? So if you cut the
Yeah.
object here in between also, you will find that there is trapezium over there, right? How would I draw that? It's very difficult to draw, but you can imagine that everywhere you'll find just a trapezium.
Yeah.
Okay, so this is about prism. The prism could be anything, like it may be cuboid, means, if how many faces are there in this prism? How many faces are there?
Um, six.
Six faces, right? One, okay, this is one. Second is behind. Third, fourth, fifth is, that just corresponds to three, and six is below that, right? So there are six faces here. Similar, if suppose all six faces are rectangle, then this become cuboid. Okay, all six faces are rectangle, like this. Okay, then it become cuboid. So I used to draw this cuboid in my school time like this. I really enjoy drawing like this. So this is cuboid. Can you figure out this? This is cuboid. Each
Yeah.
each faces are rectangle. Okay. If each face are square, each face are rectangle. If each face are square, then this become cube. Okay. So how do we draw cube? Cube is like we must show square as a face like this, and cube everywhere. So this will definitely be a cube, right? When each faces are square, it will give you cube. Okay. So what is the, if suppose in case of cube, if I give you the edge of this object is having length a, small a, then what would be the volume of this cube? So first if
Um, yeah, A into no, A cube.
yeah, a cube. So first we'll find out the area of the cross section. Okay. So volume is basically area of the cross section, that is a into a, right? And the length. So how, what is the length of this cube? That is a, right? It is not yeah, it's coming here. So that length is basically a, going inside the page. That way you can assume. So a, area into length, right? In case of this cuboid, if I give you some parameter, like the length of this rectangle is L, width is this W, and you know the length inside the page, it is going H unit. Okay. So what would be the volume of this cuboid?
Then it'll be W into L into H.
Yes. So L into W is the cross section area, which is nothing but this. And since it's going all along, the depth, so L into W into H. Okay. So this is the volume of the cuboid. Fine. Yeah. One more shape we have, that is cylinder. Okay. And cylinder is like whose cross section is basically circle. Okay. That is called cylinder. So this is cylinder. What would be the volume of this cylinder? First of all, you have to figure out the area of cross section. Okay. So what is the area of cross section? If I give you the radius of this circle is r. Okay. Radius of this circle is r, and it's going along h length. Okay. It's going inside the page, or it is basically here I have shown like this. So it's going along, that cross section is going along h. Okay. So what is the volume of this
And it'll
cylinder?
be pi r square into H.
Yes. So area of cross section into length. So that is basically pi r square h. Okay. So these are some basic information about the volume of three-dimensional object. Now let's solve some problem on this. It make you more comfortable. Okay. So the question is, I'll have to draw the object. So 7, 4, 2, so going like this, 10. So what is the uh, volume of this prism? Find it out.
So what is area of how do you find the surface area of this shape?
Yeah, no, volume you have to find out. This is your cross section. Okay, this is the cross section area,
Okay.
and you will definitely verify that this cross section is going all along the length 10 unit, isn't it? Means this is same everywhere. The cross section is same everywhere. So if we simply find out the area of this cross section, and if I multiply this by 10, we will get the volume of this prism, isn't it? So what is the area of cross section?
Okay. Um, 42.
How do you find out that? It's trapezium, right? So the
2 times 4.
no, the area of the trapezium
Um,
is, see, sum of parallel line into distance between them, means half of, like this is the formula, half into sum of parallel lines into distance between them, which is 2 centimeter, 2 unit here. All lengths are in centimeters, so that is 2 centimeter. So this will give us the cross section area, which is 7 plus 4, 11. 2 will cancel out, 11 centimeter square, and therefore the volume is area into length. So 11 into 10, which is 110 centimeter cube, right?
yeah.
Okay. So now next question. Next question is, uh, this is the triangle here. And this going inside the page like this. You will have to assume the diagram properly. Like this. So the cross section of this figure is basically this triangle, and the dimensions of this object are 9, 3, and the length is 7. Okay, find out the volume of this. Did you understand the diagram here?
Yeah.
Okay, no need to decorate this. Fine. So what would be the volume in this case?
Um, 94.5.
94.5. So the area of cross section is, it's right angle triangle, so 1 into 9
Half.
into 3, right? This is the area
Yeah.
into length 7. So whatever the answer is, okay, and the unit of this would be centimeter cube always. Never skip writing unit of the volume. Fine.
Yeah.
Okay, I'm putting up next question of similar type, then we'll move to the other part of this chapter. So the question is like this, and it is going inside the base like this. Okay, so this is, you can imagine that this is basically the prism. Okay, and
So
then,
is this half a cylinder?
yeah, it's half cylinder, and the dimension of this is basically 20 centimeter length, and the radius of this is 6 centimeter. Okay, no, not that radius, that's basically diameter of the half circle. Okay, so
Okay.
what is the volume?
So you have to divide it by two because it's only or like
Yeah, radius would be
okay.
3.
I got 282.7 centimeters squared.
uh, cube, the unit must be cube.
Centimeter cube, sorry.
Yeah, so area is basically 1 upon 2 pi r square. So 1 upon 2, 3.14 into r is 3, so 3 square. So that we can write like this, 9 by 2 into 3.14. And the volume of this is cross section area into length. So 9 by 2 into 3.14 into length is 20, right? So 2 will cancel out this 20, which is 10. So when you multiply this with 3.14, it becomes 31.4, and then 9 4 is 36, 12, 282.6. What did you say? Same
Yeah.
answer? Okay, good.
282.7.
7. So you must have solved before. For area, you must have simplified. Okay. So let's move to the next part of this, that is pyramid. Okay. We have understood the cylinder, cuboid, cube, prism, right? Now next is pyramid. So in case of pyramid, like I first of all introduce the diagram of the pyramid. That is the, see, this base could be rectangle, it could be square, okay, it can be triangle also, okay, and it will have certain height, okay, and when we connect the, you know, connect the height, that point, with uh, like this, so you would definitely observe a shape of pyramid, okay, whose height is h in this case, okay, and the base is basically rectangle, right? The base is rectangle here. So this is the shape of pyramid. The base could be anything. It can be square, it can be triangle also, okay, so it doesn't matter, but it should be connected with one point above the base, okay, and it will give you certain slant faces, right? You will observe some slant faces like this. Now the question is, what is volume of this pyramid? Okay, volume of pyramid. Do you remember the formula, or have you ever read the formula of volume of pyramid?
No.
Okay, I'm first of all I'm giving you the formula here, and then I'll try to prove that formula. So that is 1 by 3 base area, okay, 1 by 3 base area into height, okay. You just uh, try to understand the formula. Try to understand the formula. The formula is 1 by 3 into base area. Okay, what is the base here? Base is rectangle. Okay, and into height, right? So I'll try to put this pyramid inside a cuboid. Okay, inside a cuboid. Let me show you the diagram here. And okay, for that I need to draw the cuboid here. So okay, so this is cuboid, right? And I will try to put this pyramid inside this. There is a relation between cuboid and pyramid as far as the volume is concerned. Okay, so we have a central point. Okay, point here. And if I connect this point, hmm, like this, with all the vertices of this, you will definitely observe one of, how many pyramids you will observe here. You will definitely observe a lot of pyramids. Okay, with height a. This is the height. This is the height of the pyramid. And let's say the width and length and height of the cube, this cuboid, is 2a. Okay, just try to understand the diagram first of all. This is perpendicular drawn on the base. Okay, from the middle point. Okay, how many pyramid you can observe here? Like if you just look at the base part, you know this part.
Mm.
See, this is the slant face of the pyramid. Okay, and let me draw with the different color here. That is, let's say, yellow. Okay, so this is something, the face which is towards us. Okay, so did you observe the pyramid here? Just one pyramid I'm talking about.
Yeah.
Just one pyramid. Okay,
Yeah.
so we have one pyramid like this. So how many pyramid we have like this in this cube? If you can answer that, then all job is done for this. How many pyramids we have like this? It's a kind of diamond, you can understand. Like, see, the central point, the point O is just within the cube. Okay, position
Yeah.
in between. So how many pyramid we have in this cube? So I'll help you to figure out the number of pyramid in this cube. See, we have one face as a base here. Do you understand? This is the base, right?
Yeah.
This is the base of this pyramid. We have one. We have used only one base for this pyramid, right? How many such how many such bases are there, or how many surface of this cuboid are there?
4.
No,
No. 6.
six. Okay, if we include all,
Yeah.
we have six faces of cuboid. Okay, each six faces will be act as a base for the pyramid. Okay, so if you imagine, you will find six pyramid inside this cube, right?
Yeah. So there'll be 6 pyramids.
Yeah, there are six pyramid. Okay, so if I assume the volume of one pyramid is V. Okay, so how many pyramid are there in this? Six pyramid. So 6V
Yeah.
would be basically the volume of cuboid, right? In this case, it is
Oh,
cube,
okay.
right? So, what is volume of cuboid here?
Volume of cuboid is length into breadth into height.
Yes. So that is 2a into 2a into 2a, right? So we are interested in volume of one pyramid. So V is equal to 1 over 6 into 2a into 2a into 2a, right? Hmm?
Yeah.
You
So
will,
the twos get cancelled.
yeah. And actually, what is the height of this pyramid? A, right? The height of this pyramid is A, half of the total length.
Yeah.
So what I'll do, I'll use this 2 to cancel out this. Okay. So what I get here, 1 over 3 into 2a the whole square into a, right? So this is nothing but 1 over 3.
Okay.
2a the whole square is area of base, right?
So
Base area into
yeah.
a is height, right? A is height of that pyramid. So therefore the formula of this is 1 over 3 into base area into height. Is that clear?
Yeah.
Cool. So now after pyramid we have cone and sphere. Okay. So on the same guideline like we did for the pyramid, we have a volume of cone also. Okay. So I think everybody remember the volume of cone. Mostly student quickly answer volume of cone. What is the volume of cone?
Pi r square into height.
But 1 over 3 pi r square h into 1
Oh
by
yeah.
3. So you will understand the same way like we did in pyramid. So this cone will be inside the cylinder, right? I'm not going to explain this now, but
Yeah.
you can assume that the cone is basically inside the cylinder, right? And in that way we will get 1 by 3 pi r square h. Okay. And
Okay.
the next is sphere, that is like the earth. So volume of sphere is 4 by 3 pi r cube. Okay. Every time you will definitely verify one thing, that there are three dimensions utilized while writing the formula. Okay. Like r square h, three dimension. R cube, three dimension. Are you getting r into r into r? So every time,
Yeah.
since we have an object, three-dimensional object, so every time to figure out the volume, we use three-dimensional values inside the formula, right?
Okay.
That's why it gave us centimeter cube, meter cube, or unit cube, right? Okay. You want to copy down something?
No, I already took everything down.
Yeah, good. So I'm putting up next the question on this. That is, calculate the radius of a sphere of volume 500 centimeter cube. Okay. Yeah, done. This is the question. Find out the radius.
I got 1.89.
1.89. Okay, let me verify. No, radius I was saying. You got radius as 1.89?
Yeah.
You made some mistake here. See, what is the volume of sphere? That is 4 by 3 pi r cube, right? And the volume given is 500. So we simply plug that value here. 4 by 3 into pi is like 3.14 into r cube. So r cube is equal to 500 into 3 upon 4 upon 3.14. Okay, so you'll have to use calculator for this, and you have to find out cube root of the whole thing. The answer should be 4.92 for three significant figure.
Oh.
Did you get the answer? 4.92. Found it?
No, I got a different answer, but I did it wrong.
Okay. So you can manage this later, right? You can simply put the values inside calculator. It will
Okay.
show you the answer. Okay. Now next is surface area
Okay.
of three-dimensional object. Next topic is surface area. See, there are a lot of questions uh, based on the above concept about the volume of pyramid, volume of uh, the prism. Okay, so the volume of sphere, cube. There are a lot of such problems available in book. You go through that. If you find any difficulty, you come again. So I just explain you the basic idea of what is volume and area of three-dimensional object. Okay, in this class. So next is surface area. Okay, so we will figure out the surface area of the curved surface. If we have cylinder like this, what is the surface area of this cylinder?
The surface area will be
If the
pi r square.
surface area I'm saying means, if suppose there are two type of surface here. One is curved surface, right? Other is circle basically, isn't it? There are two type of surface. One is curved surface, other is circle. Did you notice all of this? Like, see, the base and top and bottom are
Yeah.
circle, right? And if you simply cut this cylinder, right? We have cylinder in our house, as well as you can imagine anything, a lot of objects available in house. If you cut that, cut, you know, one of, by this one edge, it will expand like this. And if you open up that, what you will observe? If you open up, what will you observe?
It's a rectangle.
That's basically rectangle, right? Rectangle with height h, certain height h. Okay, and if suppose the radius of the circle, top and base circle is r, so what this length is? Can you imagine what is the length of this line? That is basically
What?
the, yeah, I'm asking what would be the length of this AB if I just put the name,
The circumference.
circumference of the circle. So that is basically 2 pi r, isn't it? So the curved surface area,
Yeah.
that is same as the area of rectangle. So that is 2 pi r h, isn't it?
Okay.
And the area of circle we know, that is pi r square. There are two circle, so obviously we'll simply add one more pi r square. So total surface is one of the term while talking about the three-dimensional object, because they are different kind of area. One is curved surface, the other is circle in this case. So total surface area is equal to 2 pi r h plus pi r square. But how many pi r square? 2 pi r square, because there are two circle, right? So this is one of the formula for cylinder. Now for sphere, let me put the name. This is cylinder. Now for sphere, what is the surface area? For surface area of sphere is
Uh,
4 pi r square. Okay,
okay.
it's the observation, or you will find the different techniques, but this is not the for proof of that is not the scope of this book basically, because it requires the higher mathematics in it. Okay, and cone, the surface area of cone. So if you understand cone, so cone also have two type of surface. One is curved surface and other is circle, right? So
Yeah.
curved surface area is equal to pi r l. What is l? L is basically slant height, or that,
Length.
yeah, slant
Okay.
length and slant height. Height is little confusing because we normally denote this as height. So you can say slant length. Okay. So curved surface area is pi rl, and you know that base is basically circle. So obviously the area would be pi r square. Fine.
Yeah.
Okay. Now I'm putting up next question on this topic. Just try to solve that. So the question is, find total surface area of solid cone of radius 4 centimeter and vertical height 3 centimeter. Okay,
Yeah.
solve this.
Got 65.9.
65.9. The total area, the total surface area.
Yeah, the total area.
No, it's
It's the
wrong.
total surface area.
65.9. No, that is wrong answer. So, okay, let me explain. Maybe you have used the wrong concept for that. See, basically, what we have to find out total surface area. How many surfaces are there in solid cone?
The curved surface and the circle.
Circle. So, have you found the area of both this type? What is the curved surface area? See, for
The curved surface area was 12 pi.
is pi rl, right?
Yeah.
Radius of this cone is 4 centimeter, and the vertical height. what they've given, vertical height as 3 centimeter. Okay, and the area of, curved surface area, is basically pi r l, isn't it? That l is the slant length. Okay,
Oh, so you have to find the slant length.
yes, we have to find out slant length here. Okay, what is the slant
Okay,
height?
so it will be 5.
So if you observe the triangle here, that is right angle triangle. So how would we find the
It will be
slant
right
height?
angle.
Yeah,
So it will be 5.
that would be 5. Very good. So now we can directly apply the formula. So pi into radius is 4 into length is 5. So 20 pi. Okay. We always solve, we always calculate at the end. Now area of base is pi r square. So pi into r square is 4 square. So 16 pi. Okay. Don't forget to write the units. Now total surface area is equal to 20 pi plus 16 pi, which is 36 pi. So if you simplify this, you will get near about,
103.9.
right, 113 centimeter cube for three significant figure. Okay. Okay, now I'm putting up next question. Please be care while solving such questions. Okay, the next question is, you have to find the surface area of a prism. Find surface area of prism whose, okay, whose length is 50 centimeter and whose cross section is a regular hexagon. Okay, with side length 10 centimeter and area 172 centimeter square. Okay, first you draw the diagram.
So the area of the hexagon is 172.
172 centimeter square.
Okay.
Have you drawn the diagram? Please verify your diagram. I'm drawing that here.
Okay.
It's a regular hexagon. It means all sides of that hexagon is are equal, right? All sides are equal.
Mm.
So uh, okay, so I can draw it like this. Okay, and correspondingly we can draw one more hexagon like this, and we can connect each one of this. It gives the sense of 3D object, right? Isn't it? This look like 3D object prism, right? Whose cross section is
Yeah.
regular hexagon, and whose length is 50 centimeter. So the length of this prism is 50 centimeter, and what they've given, hexagon with side length 10. Okay, with side length 10. So obviously each side will be of 10 centimeter, and area is also given. Okay, so 172 centimeter square is the area. You have to find out total area of this prism, right? So
Okay.
total surface area.
So I think it's 3,172 centimeter
3000.
square.
No, what is the logic? Like, answer is wrong basically. What is the logic? How many faces we have?
There's six, so that means the two sides of
Base and the
the
top. Base and the top. The regular
yeah.
hexagon, right? And there are six rectangle,
Mm.
right? There are six faces which are rectangle, isn't it? Which is going like this, and there are two hexagon. So the area of hexagon is already given, which is 172 plus 172, since there are two hexagon, plus there are six faces, okay, which are rectangle. So 6 into, what is the area of one rectangle?
Length into breadth.
Yeah, so the length is 50 centimeter, and what is the breadth here?
The breadth is 60. I'm not sure.
The
10.
10 centimeter, because see, this is the
Okay.
this is the rectangle, isn't it? The length is 50 centimeter and breadth is 10, because each side of this regular hexagon is 10. So 10 into 50. Understood? That is the area of one rectangle. There are total 6 rectangle in this. So 6 into 50 into 10. So now we'll simply calculate this. 172 plus 172 is 344, plus 6 into 5 into 10 is 500, and this is 3
300.
3000. So
3,000.
3344 centimeter square. Okay.
Yeah.
Okay, now I'm giving you some questions here. You have to find out the surface area of the prism. Okay, so I'll share the screenshot of that instead of drawing that, because it will take time. So just a second. That's your, yeah, share. Yeah, can you see the image?
Yeah.
So you have to find out the surface area of this prism.
Okay.
So first recognize how many faces are there and which faces are equal. So it will reduce your time. Like we should not waste time calculating the same area, isn't it? So which faces are same? You recognize that, and you find out only one time and multiply that many times. Okay, like this face is repeated, isn't it? Which is backside, right? So what is the area of this
Yeah.
face? What is the area of this? So that we can figure out. This is basically sum of two areas, two rectangles.
Yeah.
So okay, let me put that as one. Okay, one type of area. So 8 into, see, the length of this rectangle is given 8, and what is width of this rectangle?
2.
2. Very good. So 8 to the 16, plus we have to find out the area of this rectangle now. So it's 6 minus 2, right? It's 6 minus 2. Length is 6 minus 2, which is 4,
Yeah.
and height is 3 centimeter. So 4 3s are 12.
Yeah.
So 16 plus 12 is basically 28. So same area is there, behind this object also.
On the other side.
Yeah. So this is done, right? Now, okay. So now we can find out this backside area. Okay. What is that? How many? What is the area of this backside? That is also rectangle of length 8 centimeter and 10 centimeter length, width 8 centimeter. Are you getting?
Yeah.
So 8 into 10, 80.
Yeah.
So 2 is also done. 1 is also done. Okay, 1 that was out behind that. Okay. Okay, what is base here? Base is also rectangle.
Yeah.
Base is also rectangle of length 10 centimeter and width 6 centimeter. So let me put that as 3. So 3 is equal to 60, isn't it? And there is no repetition also. Fine.
No.
Okay.
Yeah.
And what about this? This area. So
This is 10 to
let me put that as 4. So that is 10 into 3, 30. Okay.
yeah.
And mind this, we have to multiply this by 2 while calculating that. Okay. Now only area left are this and this. Okay. So let me put that as
So
5,
that will be
6.
5 and 10.
So 5,
5 times 10.
5 times 10, very good.
8 minus
50,
3.
yeah, 50. 5 times 10, 50. And this one is like 4 times 10, 40, right?
Yeah.
So
Yeah.
28 into 2 is 56. So add all of this, 56, 80, 60. There should not be any repetition. Okay, so when we add all
So
of
I have to
this,
multiply everything by
no, we have to add. Why will you multiply? These are the individual
2.
area of
Okay.
individual surface. So we simply add them together. It will give you the total area. So that is
316.
360. Okay, so that's final answer.
No, 316.
300 and
316.
316. 316. Are you sure? Like anything left here? No,
Yeah.
no, na?
No.
Okay, cool. So yeah. No, we left this part. We left this part, the top one. What is the area of this? 2
That
into
will be 5 into
20.
2.
20. 10 into 2.
Yeah.
So
Yeah, 10 into 2.
7 is 20. So when we add 20 more into this, it will give us 336. Okay, I think now it's complete.
Yeah.
It's included everything. Okay, so this is how we have to add all the surfaces. Okay, that will give you the total area. Now solve this last one quickly.